So our today's topic is latent heat. When a substance changes its state at a constant temperature, for example, we can see that from solid to liquid, liquid to gas, then we can see that heat energy is involved over here. Actually, this energy is not utilized to heat up the given system, but it is used to separate the molecules from each other. Molecules which are present for the in the given system, and this energy is called latent heat. And latent heat is not similar, and do not get confused with heat capacity. We'll discuss heat capacity later on in our videos. Now come to the actual definition of latent heat. Energy absorbed or released by a substance during change in its physical state or phase that occurs without changes its temperature. Another definition we have the amount of thermal energy, or we can say heat, that is absorbed or released when a body undergoes a constant temperature process. We have very simple example over here. For example, melting of ice and boiling of water. Now in the definition we have used the term energy absorbed or energy released. Now from the given system, from the given figure, we can say that there is involvement of heat absorbed and heat release, energy release, sorry. So when we supply heat or say energy to the ice, then it converts into water. Why ice converted itself to water? Because of the absorption of heat, or say absorption of energy. Energy is absorbed while ice converts itself into water. When we say example, our system is water over here. When there is absorption of heat or absorption of energy, then there is increase in the temperature of the system. Or we can say that when temperature is increasing, then there is absorption of energy of the system. In that period of time when temperature is increasing, then molecules far apart, uh, like break from each other. Similarly, water when present in liquid form converted into water vapors. This also happens due to the absorption of heat, or say energy absorbed by the water molecules when present in liquid form. However, when water vapors condensed to water, means vapors in vapors to liquid form, then there is decrease in temperature, or we can see that there is release of energy. Similarly, when water is present in liquid form converted to ice, then also there is release of energy or decrease in the system's temperature. One important point is here, not that latent heat is particular to state changes. For example, latent heat from ice to water will be different from when water converts into water vapor or liquid to water vapors. Or we can say we can also say that the given system may take different amount of heat energy to change itself from solid to liquid, then to change itself from liquid to gas. For example, 7 times more energy is required when water converted to water vapors than it does to melt ice into water. It means a single substance can have different kind of latent heat. Now here we have, you can see over here there is latent heat of fusion when solid converts to liquid, and there is latent heat of vaporization when liquid converts itself to gas. Now on the basis of this we have latent heat of fusion and latent heat of vaporization. So in simple words we can say that latent heat associated with the melting a solid or freezing a liquid, vice versa is also true, is called latent heat of fusion, and latent heat which is associated with vaporizing a liquid or a solid or condensing a vapor is called heat of vaporization. Now from here, let me ask you a question. At 0 degrees Celsius, ice starts melting. So we can say that at 0 degrees Celsius, we have ice as well as water. Then why we prefer ice over water for cooling purposes? Let me answer this question. It is because at 0 degrees Celsius, ice converts into water by gaining latent heat. So water has more latent heat than ice at 0 degrees Celsius, due to which ice shows more cooling effects than water at 0 degrees Celsius. On the same basis, we can give answer of another question, which is why the burn caused by water vapor is more severe than water when both are at 0 degrees Celsius. The answer is same. It is because water converted to water vapors by absorbing latent heat. So water vapors have more latent heat than water at 0 degrees Celsius. Now come to the formula of latent heat. It is normally expressed as the amount of heat which is represented by Q per mole or unit mass of substance which is undergoing a state of change. Now L is equals to Q by M, where L is our specific latent heat. Why we are saying specific latent heat? Because it is per unit mass of substance. Q is heat absorbed or released, as we have discussed. M is the mass of the substance, mass of the given substance. Now energy is considered is to be latent because it is essentially hidden within the molecules until the phase change occurs. And latent heat is an intensive property. All of you are aware of intensive properties. Intensive property of a matter means its value does not depend on the quantity, means how much amount is present. Now on the basis of the formula, I am going to ask you a question. You can answer this question in the chat box after watching this video, and then in the next video I will provide you the answer. It's very easy, just based on the formula which I have just given in the previous slide. Now calculate the heat energy required to melt 7 kg of ice when the latent heat of fusion of water is 3.34 into 10 raised to power 5 joule per kg. Now that's all for latent heat. Thank you.